So students, today I want to tell you about that work and energy. Work and energy. But before going this, we have to keep the concept of motion and Newton's law of motion. If students you are not knowing the concept of motion and the Newton's law of motion, then you will be confused regarding that. But don't worry. Second important thing is that work, whatever we are just going to talk about in the day to day life, here is having in the physics little bit difference. So let's begin with lecture. If I am teaching you, it means that I am doing what? What do you think? If I am teaching you, then I am doing what? Tell me. So work. Very good. That we are just going to talk about that. Irfan and the Pransu. If you are studying, you are doing what? Obviously, you are thinking work. If you are playing, then you are doing what? If you are playing, work. Very good. Your father is doing job, then father is doing what? Work. Oh, lot of example, students. Your mother cooking food in kitchen, then your mother is doing. Your mother is doing. Obviously, that is work. Work. Okay. Very good. So one more important thing, students, you have seen. That is work done. Obviously. But in the physics, students, just you have to think about what is work. So the force and displacement in this concern, whatever is going on, that is called work. Okay. So work done means that there should be the force, and if displacement means that there should be a some displacement happens. So work done is equal to force into displacement in the direction of force. All of you note it down. This is a very important formula. Force into displacement in the direction of force. Okay. Done? Good. So here you have seen that we are just applying the force and the displacement in the direction of force. That is the means work done. Do the one activity. All of you go and get a book. All of you go and get a book. Quickly. All of you go and get a book. I got a book? Okay. Now, you hold the book. Have you hold the book? All of you on the video, please. All of you on the video so that I can see the activity you are doing. Have you hold the book? Now tell me the work is done. Tell me the work is done. If you hold the book, now You lift the book. You lift the book. So this time work done, or when we hold the book then work done? Tell me. Please on the video. Oh, Adarsh Tiwari has given me the answers, that correct answer. Whenever we lift the book, yeah, obviously students, that is the meaning of that particular things. Pransu Sharma, both. My dear, in the physics little bit having the go and got, and this is happens. So what that whenever we are just lifting the book, then it is happening. How it will happen, I will tell you. Let's go for that. What is energy and why do we need it? Let's first, I want to give you the answers, and after that, when you lift the book, see, this is the displacement and the force is applying. If you hold the book, no displacement, so there is no work. I have already said to you students, if you hold the books, you are doing the works? No, because there is no displacement into it. But now you lift the book, it means the some displacement happens. Here the force is also there and the displacement. Yes, here the work done. So because force also involved and displacement are also there. So the both is involved here, so that's why the work is done here. I hope that it is clear. Let's have one question. If you are applying the force 10 Newton, if you are applying the force 10 Newton and displacement is 40 centimeter, tell me. So how much work done? You know the formula. How many work I have done? Tell me students. Here the many students given me 400. What is the unit? Shreyas, Adarsh, Pransu, you have given me the answers, but what is the unit? Correct. Force into displacement, the 10 Newton is the force and the 40 centimeter is the displacement. So what is the unit? So that is 400 Newton and centimeter is the unit here. So the work is means that a joule. So I am coming on that students, that is the what is energy. I think the work is clear to you all. What is energy? Energy means that the ability to do the work. So moving an object, how the object is moving? Because we are exerting the force. So we are applying the force, then object is moving, or force is a push or pull. So whenever you are just force is used to move an object, so what we required students? We required the energy. If I am speaking, what I required? We required energy. Very good. 10 students given me the response. Very nice. Aljam, Aljaman, Irfan, Pransu, others. Very good. So students, the ability to do the work means whenever you are just doing the work, so whenever you are just doing the work, you have seen that moving an object by exerting a force, okay, exerting, and how the object is moving because of force. So whenever I am talking about the force, force is a pull or push. So whenever the force is used to move an object, energy is required. Energy is required. So students, you see the energy is the ability to do the work, and the work is means what? The moving an object by exerting a force. It means that if any object is moving by exerting a force, that means that is the work done. But in the work I have already shown you the force and the displacement both are required, and the force means what? A push or pull, that is called force. So whenever force is used to move an object, energy, students, so energy is required. Force is used to move an object, energy is required, student. So whenever you walk, whenever your muscles pull or your bone is ordered to move your body, so these all are required force. So this requires your muscles to use the energy. How the muscles will work? Because of that, when you will apply the force. So energy means that how much you are doing the work. Without energy, students, there could be no motion. If you are not having energy, you cannot do the any motion. Okay. So energy is a very important role playing here. So atom and molecules also cannot move. A star could not shine. Okay. So that question is here. The atoms is what? That is the basic building of the matter. So planets could not orbit around the star. Okay. So animals could not walk, run, swim or fly. So we need energy everywhere. If you want to walk, energy is required. If you want to run, energy is required. If you want to swim, then energy is required. If the birds want to fly, energy is required. If the planets could not orbit around the star, energy is required. So that atoms and molecules could not move, stars could not shine. Energy, there could be no motion. So energy, students, everywhere is important. So the wind could not blow, message could not send from your brain to your body. So that also the energy is required. It means that if you are thinking too much, the lot of energy you are using. So be careful whenever you are just using the energy, that time you must have to be sure, is it important? So I think students, here is any doubt? Let me ask first. So here students, you have seen, next question arises here, is work being done when you hold a book over your head? The book is on the head. All of you hold your book on the head. What is the answer? No. No. Very good. Thank you. Why no? But it did take work to get is there. Whenever work is being done, energy is being used. Here the energy has transferred but not used. Okay. So the energy was transferred from your body to the book. How much work is being done? We can measure the amount of work being done to move an object, students. So we can measure the amount of work done to move an object. We need to know two things in order to measure work. One is that how much amount of force being used, and second one is that what how much distance of the movement. So we can calculate the work using the following formula. So all of you write down, work is equal to force into distance, or either the work is equal to force into displacement. Done? how much work is being done if the person is applying this much force and this much distance cover, or either this much displacement is there. So that we are going to be find it out how much work has been done. Okay. Unit of measurement. Whenever we are just talking about the calculating work, so students, that here you must understand, so unit of measurement, whenever I am talking, so here you have seen, just a minute, you give me the 1 minute time. Okay. So I was just talking about that a unit of measurement. Whenever the object, work, use the following unit. Students, we are knowing that the force we are measuring. So what is the unit of the force? That is Newton. And that a distance is measured in the form of meter, or the displacement is the centimeter. And work is measured in the joule. So 1 joule is equal to the 1 Newton multiplied by 1 meter. Okay. 1 joule of, when you pick up an apple, so you pick an apple and put it on the desk, right? Sample example here, if you lift a 3 Newton box 2 meter off the floor, how much work if you have done? Calculate quickly, very fast. Six joule. Pransu and others. Thank you. It is the 6 joule. So work is equal to force into distance, and 3 newtons and 2 meters, and that is the 6 joule. Clear, students? If you lift a 3 Newton box 2 meters off the floor, how much work is done? You have seen work is equal to force into distance, and 3 newtons and plus 2 meters, and that is the 6 joule. Clear? So you did 6 joule of work. This unit is very important, students. If you are not writing the unit, then definitely it will deduct the marks. So please take care whenever you are doing something. So that time you must check their units. So students, if you are lifting until 3 newtons box and the 2 meter off the floor, how much work done? 6 joule of that work you have done, students. Question: when you carry a heavy bag of groceries from your car, right? So when you are just going to, when you carry a heavy bag of grocery from your car to your kitchen, so what does most of work? Your arm or your leg? And explain why. Nandini Singh, tell me. Rajiv, Yug Verma, tell me, students. Very good. Anyone having? Question is very simple, students. When you carry a heavy bag of groceries from your car to your kitchen, what does most of the work? Your arm, students, or your leg? Who will give me the answer? 6 students. Very good, students. Very good. Aljaman, others, Sejal, and Irfan. Very good. So, students, you have seen that. So, anyone have any answers? So, students, here that this question. Yes, your leg, not the arm. Meeting will end after the 10 minutes, but again immediate I will connect. So nobody will go out. Okay. I have taken attendance. If anybody will be out, then he will be responsible. Again I am telling you. So students, here what is working? Your leg. Why? Because they move you and the grocery from the car to the kitchen. And your arm only lift and hold the grocery. But you are moving through the leg, so that's why your leg, when you carry a heavy bag of grocery from your car to your kitchen, your leg is working too much. Clear, students? So this is the answer of this question. And the leg is applying. Here also you understand. The leg is applying more force over a greater distance, so they do more work. So that means that your leg is doing more work for moving that particular object. So students, this was the answer of this question. I hope that work done of an object is defined. So with this we can say the work done on an object is defined as the product of magnitudes or the force acting on the body, students. So the product of the magnitudes of the force acting on the body and the displacement in the direction of the force. So if the force acting on the body cause no displacement, if a force acting on the body causes no displacement and the work done is 0, it means if there is no distance covered by the body, that means the work done is 0. Okay. So students, you are pushing a wall, you have already done this activity. Wall is stable on that place. You are applying force, agree, but that displacement is 0, so no work done. So in this and daily life, that is the too much differences. Whenever we are talking about the work, we are keeping in mind that there should be some displacement. Clear, student? energy. Energy is defined as the ability to do the work. Already we have discussed. If unit is same as that of work, so SI unit of energy or work is equal to joule, Newton meter, or either we are just going to calculate the kilogram meter square per second square, either this joule, Newton meter. Have you written? Energy has a different form, students. You have seen the bulb. Bulb, which energy? Bulb, which energy? If we walk through our hand, very good, Ved Singh. It means you are holding the vegetables in your leg and you are walking through the hand. In that case, the hand is working too much. But I haven't seen that this type of the things happens. Mostly the students are holding the bag by the hand. So thank you, Ved, for updating my knowledge. Pransu, you are also same thing. So here that leg is working too much, students. Energy. If I am talking about the energy, that a bulb you have seen that. Which type of energy it is just producing? Yes, students. Which type of energy it is providing? Light energy. Right? Very good. And you have seen that some appliances, you tell me who is producing the heat energy. Tell me, heat energy. Microwaves, okay. Light energy, Sejal. Thank you, only the Sejal has given me the answer. Others has also given bulb. Thank you, Irfan. Chemical energy. Chemical energy, filament, bulb. No, okay. Electrical or mechanical energy. So whenever students we are just talking about the potential energy and kinetic energy, so that sum of kinetic energy and potential energy is called mechanical energy, students. Okay. So here in this picture you see the one girl is standing. So when it is holding the ball, so this ball is having their potential energy. So in this ball is having potential energy. After that you see this potential energy transform into the kinetic energy when it is just living. And when this potential energy and kinetic energy you will press, then it will become mechanical energy. Okay, students? So kinetic energy, object in the motion passes energy and can do work. So write down this thing is very important. Object is in motion, possesses energy and can do work. This is the important thing. The object is in motion, possesses energy and can do work. This energy is called kinetic energy, students. Here you see the F is equal to m into A. force is equal to mass into acceleration. Also have that work done F into S, the force into distance, whatever the cover up. From the second equation of the motion, students, so here what is the second equation of motion? Who will give me the answer? Second equation of motion. Anyone? Newton's second law of motion. What is the motion? Tell me the formula quickly. Aryan, Manish Rai, Shreyas Shukla. Where is Shivans Pathak? Yes, Shivans Pathak, tell me. My question is very simple, students. Nandini Singh. Okay. V minus U is equal to 2 yes, Pransu. Thank you. So, students, here you see the V square minus U square is equal to 2as. So, here from the second law of motion it was just came. So, V square minus U square is equal to 2a. So, this is the substitution equation for work done by moving object. So, we get, students, work is equal to mass into acceleration into V square minus U square by 2a. So, this way we are just